Welcome to The Explainer. Today, we're diving deep into the mind of an AI. We're going to break down how it remembers, how it forgets, and why the privacy of that memory is one of the single biggest challenges in tech today. So let's start with something I am sure you've run into. You're in the middle of a great conversation with an AI, you've given it all the context it needs, and then poof. It completely forgets a key detail you mentioned just a few minutes ago. It's super frustrating, right?
Well, what's wild is that this isn't a bug, it's actually a core feature of how these things are designed. See, unlike our brains, a large language model has absolutely no built-in, persistent memory. The best analogy is to think of it as a brilliant, world-class expert who also has total amnesia. Every single time you talk to them, you have to hand them a complete set of notes to get them up to speed.
So that begs the question, right? If AI has no actual memory, how on earth does it manage to follow a conversation at all? Well, it all comes down to some really clever engineering tricks that are happening behind the curtain. Okay, so the most basic trick is something called the context window. The easiest way to think about this is like the AI's short-term attention span. It's a temporary notepad where your current conversation is being jotted down. But, and this is key, the moment you start a new chat, that entire notepad gets wiped clean. And this is where it gets kind of wild. It's not like the AI remembers what you said before. No. With every single new message you send, the system literally sends the entire conversation history back to the AI. It's rereading the whole thing from the very beginning every single time, just to keep up with what's going on.
But here's the catch. That attention span, that context window, is not infinite. Now, sure, modern AIs have absolutely massive windows. Some can handle over 1 million tokens, which is a ton of text. But even that can run out in a really long or complex chat. And once you hit that limit, the oldest parts of the conversation just get dropped. The AI literally forgets what you talked about at the beginning.
So to work around that problem, developers use some short-term memory tricks. It's kind of like automatically summarizing the first few paragraphs of the conversation to make room for new stuff. It's a clever way to help the AI manage a longer chat within that limited attention span, at least for a single session. Okay, but that's all just for one conversation. What about remembering you? You know, your name, the projects you work on, your preferences, from one day to the next. For that, an AI needs long-term memory. And this is where it gets really interesting, because this isn't part of the AI model itself. It's more like an external brain, using databases to store information that lasts across many different chats. Let's go back to our amnesiac expert. The AI's long-term memory is like their personal librarian. Before every single task, the librarian sprints to the archives, pulls all the relevant files and notes, and puts them right on the expert's desk. And this whole process has a technical name, Retrieval Augmented Generation, or as everyone calls it, RAG. So here's how that librarian, the RAG system, actually gets the job done. Let's say you ask a question about a private document. The system first searches that external knowledge base, that library of your company files. It finds the most relevant snippets of text, grabs them, and then stuffs them into the AI's prompt, right alongside your question. Only then does the AI see everything, giving it the perfect context to give you a really precise answer. Okay, so this all sounds amazing, right? We've basically given our AI a perfect memory. But, and this is a really big but, we've also just created a huge new security risk, a whole new attack surface. I mean, just think about it. As these systems become the live working memory for our personal lives and our companies, storing our private documents, our emails, our personal details, that memory becomes an incredibly valuable and incredibly vulnerable target for attackers. It's a goldmine. And these threats are very, very real. You've got stuff like data leakage, where an AI might just accidentally blurt out sensitive information. Then there's data poisoning, where an attacker could hide malicious instructions inside a document. But maybe the most insidious threat is a really sophisticated attack called embedding inversion. Now, you really have to wrap your head around this one. To an AI, your documents aren't stored as words. They're turned into these complex mathematical things called embeddings, basically just long strings of numbers. For a while, people thought this was a good way to anonymize data, but it turns out attackers can actually reverse engineer those numbers to reconstruct the original sensitive text. It's like being able to perfectly reassemble a shredded document. It's terrifying. So, this all leads us to the most critical question of all. How can we build an AI memory that's super useful and powerful, but also fundamentally private and secure? A huge part of the answer lies in a technology called confidential computing. See, normal encryption is great for protecting data when it's just sitting on a server or moving over the internet. But confidential computing protects data while it's actively being used. It does this by processing it inside a hardware-based digital vault that no one, not even the people who own the server, can peek inside. And this is where technologies from companies like Oasis are really leading the way. They build systems that use these secure hardware vaults. This makes sure that when an AI needs your private data to answer a question, all of that processing happens inside the vault, completely shielded from the server and its operators. This creates what we call a trustless system, meaning it works securely without you having to trust the company running the AI. So what does all this really mean for us, the users? Well, it points to a future where your personal and professional digital history isn't owned and controlled by whatever AI platform you happen to be using that day. The ultimate goal here is to create what's being called a sovereign memory layer. Imagine your AI's memory not as some feature locked inside a service, but as a personal asset that you own and control. One that you can take with you and plug into any AI assistant you choose, all while keeping your work, personal, and family data completely separate and secure by default. When you combine these persistent, long-term memories with the ironclad security of confidential computing, we can start to build AI that isn't just smarter, but that's fundamentally user-owned and secure. And that leaves us with a pretty fascinating final question. If your AI's memory becomes a secure asset that you truly own, what will you empower it to remember for you?